Okay, we are over problem number 2 of the homework, which is creating the simulate model. So we need to implement and plot the output of an integrator. And we have the input here, it's a sine 2 pi t plus 1. And we need to plot both output and input signal. So I already have here my Simulink open and the library. Just gonna speed up a little bit. So we go to sources. I can find my sine wave here. Just click and drag it. I can use the continuous block. I can get my constant here. And I need a scope from here. I need a sum. And I need an integrator, which is right here. So I don't need my library anymore. I can just expand this. I press the spacebar right there, and what it does, it just brings to your screen what you have there. Okay, so the frequency of the sine wave is 2 pi. So I'm going to change that for 2 pi. Amplitude, we can leave it at 1. We have the constant. This is going to create my DC offset. And have both my sine wave and my constant going to a summator. So this is going to be sine 2 pi t plus 1. And then I have my integrator. And then I have my scope here. Okay, now for the initial condition of the integrator, if we look in class last time, the integral of a sine is a cosine, and it's at 0, it's going to be minus 1, but we have this plus 1 right here, so at t equal to 0, this is going to be actually 0. So we're going to leave it at 0 there, and we'll have a scope. And then if you hold down Control key and click, you can get like a copy of that. So we're going to look at the input of that integrator. So the homework asks for both output and input. So we can run this. And let's look at the input. So here we look at the input. We can look at kind of as a sine wave. And you look, this is really choppy here. And what is causing that is it has an auto time step. And you just kind of make it faster. If you actually want to look at those lines, you can go to simulation parameters there, and instead of using a variable time step, you can use a fixed time step. And we can do it 1, 8 to the minus 4 should be good. That way I'm forcing the time step to be really small. Now to solve it, now it's more like a sine. Okay, so here it starts at 1 because I have with that DC offset, and we can see the average value is 1. So sine wave with a DC offset of 1. Now if I look at my output, what I have is this guy here. Since we have a DC offset of 1, so the average is 1, every time, every second, I'm adding 1. You can see here at t equals 1, I have 1, 2, 3, 4, and this is just gonna keep going. By default, the time to simulate is 10 seconds, so 10 seconds, the value is 10. And if we keep running for longer, you're just gonna keep adding into that form. So this is how you do the homework.